here we have z is equal to x cubed plus x squared y plus y to the fourth. Now I'm going to ask you to write this down and pause the video and try it yourself. You're supposed to find the partial derivative of z with respect to x, partial of z with respect to x squared, the second partial derivative, I should say. I should have this as x squared. So it's delta square z by delta x squared. Alright. Then the first partial of z with respect to y, and then the second partial of z with respect to y. That means you're going to find delta z by delta y and delta square z by delta y squared. Alright, so I want you to work it out and then we look at the question at the solution together. Okay, good. Have you paused and worked them all out? Let's work them out together. So let's look at this. The partial of z with respect to x is equal to, so remember, you have two letters here, x and y. Now when you're finding the partial of z with respect to x, you're going to treat y as if it's just a number for the time being. Alright? So this means you're going to, if you differentiate each of them separately, you would have the partial with respect to x of x cubed plus the partial with respect to x of x squared y plus, and then the partial with respect to y to the fourth of x. So when you differentiate x cubed with respect to x, you get, well, in this case it's going to be 3x to the 3 minus 1, but then 3 minus 1 is 2, so it's 3x to the 2, which is 3x squared. Alright? Then what is the partial of x squared y with respect to x? Well, you treat y as if it's just a number, so you're not going to interfere with it. So you have 2, so you bring down the 2, it's going to be 2x. Now 2x to the 2 minus 1 is 1. So it's 2x to the 1. It is just 2x times y. Let me write the 2 a little bigger. It's kind of small. So it's 2xy. Alright? And then here now, the partial with respect to x of y to the fourth. And by the way, let me put some space between this and y to the fourth. So it's a partial of y to the fourth with respect to x. But that means you're going to differentiate y to the fourth with respect to x. But remember now, we're differentiating with respect to x, so x is the variable. So you're treating y to the fourth as if it's just a number. It is a constant. You remember now, when you differentiate a constant with respect to x, you get 0. So all of this will amount to 0. But when you say plus 0, you might as well not even bother putting it. So what you have there is 3x squared plus 2xy. Alright? After that now, we want the second derivative with respect to x. So you differentiate with respect to x again. So you bring down the 2 in front, and you're going to multiply. So you have 2 times 3x to the 2. You reduce the old power by 1 to get the new power, so it's to the 2 minus 1. Alright? Plus, when you differentiate 2xy with respect to x. It's like you have 2y times x with respect to x, and all of this is just a number. It's as if you had said 5 times x. Alright? Because y would be just like a number. So in this case, what you're going to have is just the number left. Because it's x to the 1, bring down the 1, times x to the 1 minus 1 is x to the 0. So x to the 0 is 1. So all you have left is 2y. Alright? So it's 2y. Let's fix this part up. X to the 2 minus 1 means x to the 1, which is just x. And 2 times 3 is 6. So what you have is 6x. Oh, by the way, no. My mistake out here. 2y times x. There was no x, so it's really x to the 0. Right? It was my mistake. 2y is just a number. So the x here is invisible, you know. But you can write it as x to the 0, which is 1. Because 2y means 2y times 1. So it's 2y times x to the 0. But x to the 0 is 1. So that's what you have. So what you're going to do is bring down the power, which is 0, times all of this. And when you multiply whatever it is here by 0, you're going to get 0. But saying 6x plus 0 is just the same as saying 6x. Alright, so here, this is what you have. The second partial derivative with respect to x. What's the first partial derivative with respect to y now? So remember, this here is really just a number. You treat it as it's a number. You're treating x for now as if it's a number. So when you differentiate the number or constant, you get 0 plus. This is y. Is y to the 1. And of course, x squared is just a number. When you differentiate this, a number times y with respect to y, you'll get the number. So it's x squared, right? Using the same argument we did earlier for x. Then this one now, differentiating this with respect to y, so it's going to be plus 4y to the 3, because you bring down the 4 here, 4 times y, and then you say 4 minus 1, which gives you 3. Now 0 plus this, you don't have to show the 0. So what you have here then is just x squared plus 4y cubed. Alright? So that's what you have there. Now we want the second partial derivative. So you differentiate this again with respect to y. Now this x squared here, remember it came from the x squared y. This x squared is just a number. It's a constant. And when you differentiate constant, you get 0 plus 4y cubed. You're going to bring down the 3, and it's 3 times 4. Writing x 3 times 4y to the 3 minus 1. Well, 3 minus 1 is 2, so this is y squared. And of course 3 by 4 is 12, so this is 12. 0 plus that, you don't have to have the 0 plus there. So what you have as the answer here is 12y squared. So that's what you have there. If you didn't get those, I want you to rewrite the question and try it again without looking back at what I did. Alright? Until you can get it all correct by yourself. So I'll see you in the next video.